Okay then guys, right, I'm on I think fourth video on rates, and the purpose of this is to sort of pull together a few things that I've tried to introduce to you with a couple of exam questions. That's about the quickest way I can do it, and in theory these questions are worth 4 or 5 marks, and they're marks to be had. Okay, there's other stuff in rates that is more difficult that I'll have to deal with later, but these will get, if you get one of these in the exam, they should be absolutely straightforward and you should be able to do them no problem. So let's have a look at this first one then, shall we? Right, the information is this. Question number 1. All right, it says chlorine dioxide, never heard of it, don't care, formula ClO2, reacts with hydroxide ions, okay? Reacts with hydroxide ions, full stop, okay? The reaction, now there isn't an equation, so I'm not sure how, I think, right, I'll do that in a minute, right, but let's just stick to this. Reaction, hydroxide carried out three times. Okay? Now, okay, so it looks to me like it's going to be a disproportionation reaction. But anyway, action carried out three times. Right, these are what I need you to do, right? Determine the order with respect to each reactant, of which there appears to be two reactants, 1 and 2. No overall equation, that's unusual, okay, because they sometimes relate to the overall equation, or something is made like a gas, and I think chlorine gas is made here, so you can use the evolution of chlorine gas to get your data like that, and then you can do a rates on it for different starting concentrations of that and that. I'm guessing here, but that would be my thought, okay? Anyway, determine the order with each reactant, 4 marks, okay? Number 2, give the rate equation. Right, 1 mark. Overall rate equation. Deduce units of the rate constant, okay? And moving to red, because this is new, okay? I'll put it over here, give yourself some space. Calculate the value of K. 1 mark for that, 1 mark for that. So 4, 5, 6, 7 marks. Now, to be fair, it's an old spec question, probably less marks these days, but quite a lot always, even on new spec papers. And again, it just depends. Sometimes even new spec, you've got some quite easy rates questions. The harder stuff we'll deal with later. Anyway, calculate the value of K. Right, so, enough waffle. Here's the info. Experiment. 3 experiments. Concentration of this chlorine dioxide in moles per dm cubed. Concentration of these hydroxide ions, the second reactant, and rate. Remember, moles per dm cubed, moles per dm cubed, moles per dm cubed per second. Experiment 1. We start off with an initial concentration of 0.01 moles per dm cubed. okay, and we start off with a concentration of 0.03, okay, moles per dm cubed of hydroxide. We do a rate, we run the experiment, evolution maybe of chlorine gas, whatever. We do a tangent, we calculate the gradient, the rate drops out at 6.00 times 10 to the minus 4. Okay, experiment number 2, 0.01, 0.075, okay. Rate now, has the rate changed? Yes, it has. 1.5 times 10 to the minus 3. Okay. Do the experiment the third time. 0.03. 0.03. You just get this in the exam. Okay. 5.4 times 10 to the minus 3. Okay. Right, there you go. Question number 1, determine the order with respect to each reactant. Okay, right, this is how I would answer this in the exam. You tell the examiner what you're looking at. You're comparing experiment 1 and experiment 2, so there's no doubt. Okay, look at experiment 1. What's going on? Well, the constant, that's kept the same. Okay. You do get ones where you ought to two at the same time. We'll have to do that later. That concentration has gone up 2.5 times. Okay? Right? And 6 times 10 to the minus 4, times it by 2, 12 times 10 to the minus 4, times it by 2.5, right? 15 times 10 to the minus 4, which is 1.5 times 10 to the minus 3. In other words, that's gone up 2.5 times. So you can get halves in there. Okay? But that's not enough in an exam, so you need to put this. Comparing experiment 1 and 2, concentration of the hydroxide ions has gone up 2.5 times. Okay? Rate increased 2.5 times. Therefore, reaction is first order. I think I told you that wrong in one of the first videos or whatever. First order. That goes up 2.5, that goes up 2.5, what you call a linear proportional relationship, whatever it is, right? First order, okay? Job done. Look at the next one, 2 and 3. Okay? So, 1 and 3, you idiot. 1 and 3. This one, so 1 and 3, okay, your hydroxide concentration is constant. Maybe I should have written that on the one above, to be clear. Stays the same, right? The chloride concentration, 3 times. What's happened to the rate? 6 times 10 to the minus 3. Well, if it's doubled, it'll be 12 times. So if it's 3 times higher, it'll be 18 times 10 to the minus 4, but it ain't, right? Basically, three times that to that, 9 times, which is good. That's a squared relationship. That means second order. Okay, so rate has gone up 9 times now. Therefore, reaction is second order. I've missed a little bit. With respect to, I like that phrase, it's a bit old school, but it tells the examiner exactly what they're talking about, that concentration. reaction is second order with respect to that. Okay? That's how you answer it. So therefore, the rate equation now looks like this. Equals, okay? It's two reactants. There. What we're saying. That one, first order. You don't have to put a 1 in there, but I like to do that because I just prefer it because I'm a bit slow. Okay? Second order squared. That's the rate equation. Okay? So, in this case, 4 marks for me. Thank you very much. Happy smiley face. Done. Okay? Then, look at, let's get the rest of the marks. Calculate the rate constant for this reaction. Okay? State the units, if any. Give your answer to an appropriate number of significant figures. Right, well, let's have the units first. Okay? The units, just as we did in the previous video, rearrange this. Rate divided by that. You don't even have to, right? So, moles per dm cubed. The bracket round it. Moles. Rate, moles, dm to the minus 3 per second. Okay, this one, moles, dm cubed, right, squared. Okay, so sort this out, cancel that, open it up, equals, you've got seconds to the minus 1 left on the top. And open this up, moles squared dm to the minus 6. Lift them by changing the sign. There's your units. Okay. Happy days. Right. Then, how do you actually calculate the value of the rate constant? That's easy. And basically, this would be in a table. A bit clearer if I put the lines in, perhaps. Okay. Now, basically, what we're talking about here. You pick one set of values and put the number in. Okay. So, if you want to calculate K, any set of values you like, you might want to try this. So whichever line you take, okay, should work out with the same value of K. Always, 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 all right? So pick whichever line you want. Okay, let's just do line 1 is equal to the rate, 6.00 times 10 minus 4 divided by this thing, 0.01 squared. Okay, it's second order for that, so taking that squared, got to square it, that's it, just taking that line, okay, and 0.03 first order for that, there you have it. Right, you bang the numbers in, you get an answer. K is equal to, now of course, I haven't actually worked this out on my calculator, I do have something written in here on this paper, which comes to 200, right, question mark. Check it. I'll have a quick, I don't appear to have a calculator handy in the room at the moment. I don't know where they've all disappeared to. Apparently this comes to 200, we will see. But you could use the second line to confirm Right, doesn't really matter. Third line, let's just do that, shall we? 5.4 times 10 to the minus 3 divided by this stuff squared, this stuff OH on its own. That should give you the same answer. If it doesn't, don't bother me because I haven't got a clue. Now, how much time have I got left on this? 15. Okay. Right, I'm going to do another one. There you go. That's it. That's how to get all the marks. But like I say, check these. What matters is that they're the same. And do the third line as well. Make sure you can calculate the value of k. So we've got the value of k, we've got the units of k, and we've deduced the rate constant from the experimental data. Jobs are good. Okay? Right, now next, speeding up slightly. I wasn't going to do book them out as well. Example number 2. Keep it on the same if we can. I'm going to upload all these videos. Great. Anyway, whatever. Okay, example number 2. Just bear with me, guys. Here it is. Is a good one? Right, abbreviate it. Right. Hydrogen peroxide, H2O2, reacts with iodide and H plus, right? It's not giving you the actual reaction. Okay? Iodine is formed. No overall equation, which is a bit of a shame. Anyway, oh, hang on, I got one here. Overall equation. The stoichiometric ratio, not the rate equation. Right? And I'm just telling you now, they ask you why this is unlikely as an actual rate step, because you're not going to get all these particles colliding together simultaneously. So the rate equation would be totally different. Anyway, you make iodine and you make water. Okay, and naturally, the question asks you to deduce this equation. It's a good idea for you to do that. Okay, jump the gun a bit there, but there you are. Anyway, so you've got that and that, all reactors involving that and that. Right, experiment carried out, job done. Right, so, experiment. Hydrogen peroxide concentration. Iodine concentration. Acid concentration. Rate. Experiment number 1, 2, 3. Okay. Start off 0.05 of that moles per dm cubed. 0.01 moles per dm cubed. Yeah, let's put the lines in. Okay. 0.05 moles per dm cubed. Right, 5.75 times 10 minus 6. Number 2, 0.05, 0.02, 0.005. Okay, as that, so kept that the same, doubled that. What about our equation? 1.15 times 10 to the minus 5. Okay, third step. 0.05, 0.04, 0.01, 2.3 times 10 to the minus 5. Right, okay. Question is, the rate equation deduced. Okay. Number 2, I want the units. And I want K, the value of K. Right, rate equation, let's have a look. Well, is there anything we can start with? There's 3 different, oh yeah, and there's one more piece of information because, right, well, let's have a look. Let's have a look. Experiment 1 and 2, kept that the same, doubled that, kept that the same. So that's all right. So 1 and 2, okay. Concentration of the iodide. Oh yeah, and another one, number 4. How do you get the data? How do you measure the continuous rate? How do you do that? Okay, experimental side of things. Right, it's all here in this. So iodine concentration has been doubled. What's happened to the rate? So I'm just getting it read out. Times 2, rate times 2. Okay, rate times 2. Therefore, first order with respect to iodide concentration. Right there. Okay. Now, 2 and 3. Say, watch this. You should do this yourself. You should have stopped the video and do this yourself. I should have made that clear. You don't think of it yourself, you've got no chance. Okay? Right, look at 2 and 3. Right, well, iodine concentration is doubled. Okay? H plus changing 2 things simultaneously. First time we've seen that. Is also doubled. The rate is doubled. And we'll do more of this, changing 2 things to see what effect it has on the rate. But we'll do that later. Rate is doubled. Conclusion. Okay? Right. We know it's first order with respect to this. Okay, let's do a bit of red. So if you times that by 2, you'd expect the rate to double, which it has. 1.15 times that. Right, that's doubled. Now, if this has an influence, you expect that to show on the rate, and we'll do that when we change 2 things at the same time. But this has been doubled as well, and the rate, that's had no effect. Doubled that has doubled the rate, first order. Doubling that, no effect at all. It hasn't made the rate change. It's just doubled. In other words, you can deduce from that conclusion it's 0 order with respect to H plus. Right? So you could put rate stays twice. This doesn't seem to affect it at all. 0 order. It's deducible. No problem. Right? So, quickly, therefore, H plus concentration has no effect therefore 0 order. Right. You might be thinking, hold on a bit, the, what's it called, hydrogen peroxide, that's not changed at all. Okay, and it hasn't. So you can't make any conclusions about that at all based on this data. You can't decide what the order is for hydrogen peroxide from that experimental data because you've not changed it. Okay, but happily, second part of the question says reaction first order with respect to hydrogen peroxide, it's telling you concentration. Okay, telling you that because you can't get it. Alright, so rocking and rolling, we've got this now. Rate equals. Just been told that. First order. Iodine, iodide even. First order. Okay. H plus. We altered that. No effect. Zero order. That's the rate equation. That would, should, could get you the marks, but I suppose for mathematicians, K, you idiot, I always forget that K. You've got to have a K, otherwise you've added the rate constant's always in there. And rate equals K, H2O2. You can drop the 1. I don't. You can drop the 1, and that one doesn't even have to be in the rate equation whatsoever. So that's probably the best way of doing it. That's the rate equation. Right, now units. K equals rate divided by okay, so equals. Okay, get rid. Equals. Lift it. Moles to the -1. dm to the 3. Seconds to the -1. Lifting it up. Lifting that up to the top. Right, value of K. Right, you pick a line of results. Top line. Substitute them in. Right. All right with that? You don't need to put that one in. It's not in the equation because it's zero order. Work it out. Comes to. Guess what? Don't know. I ain't done it. I ain't got a calculator. Either way, you work it out, right, based on that line of data. Then work it out based on that line of data. Should be the same. Then work it out based on that line of data. Should be the same. Okay? So there you go. Finally, last thing, how do you measure how do you get a handle about how fast this reaction is going? How do you measure the rate of the reaction, or how do you measure the progress of the reaction and calculate the rate of the reaction, the initial rate of the reaction? Answer, you look at the overall equation. There it is, you're going to make iodine. Iodine in water is brown. The solution will go gradually darker brown, okay? So you're going to get a graph, right? As the concentration of this stuff goes up, the concentration of it is directly related to the colour of the solution, so you need a colorimeter to give you a value for how that colour changes, okay? And then you can calculate the rate from that, okay? Because actually the colour of it is the same as the concentration of it. So you can actually have a nice graph here where you've got concentration of iodine from the colour straight away in one step. Sometimes getting the concentration from the colour can be tricky against time. So actually your units of rate are going to be changing concentration, moles per dm cubed, per second straight away from a colour graph like that. Do the initial rate, so the initial rate for that one, change things, run the experiment, get another graph, use a colour emitter, do the initial rate for the second one, do the initial rate for the third, you get those values there. Okay, so that's the way it is. Okay, guys? Alright, that'll do me.